Today we are going to see about hierarchical clustering. So you can imagine that you have a bunch of different animals like eagle, peacock, lion, deer, etc. You want to put them into groups based on how similar they are. At the beginning, each animal is in its own group. So every animal starts alone, combining similar groups. Next we have to combine similar groups. We look at all the animals and find two that are very similar. For example, maybe two monkeys are quite alike. We put them together in a new groups. So instead of having two separate monkeys, we now have one group with both monkeys. We keep doing this, putting together the most similar animals into bigger groups. It's like making a chain. We keep adding links until all the animals are in one big chain. This chain looks like a tree with branches and leaves, and we call it a dendrogram. Now we can decide how many groups we want by cutting the tree at a certain level. If we cut it higher up, we get fewer big groups. If we cut it lower down, we get more small groups. It's like deciding how many slices of cake we want. The tree shows us how similar or different the animals are. Animals that are grouped together near the bottom of the tree are very similar, like siblings. But animals that are far apart on the different branches are less alike, like distant cousins. So, hierarchical clustering helps us organizing animals based on how much they are like each other. It's like putting them into big family tree to see who's more closely related. Next we can see KD trees. KD trees are a data structure used in machine learning for efficient search and retrieval of multidimensional data. Let us see the first one, organizing data. You can imagine you have a big collection of points in space, like stars in the night sky. KD trees help organize these points in hierarchical way that makes it easier to search for them later. Then second one, splitting space. The key idea of KD trees is to split the space into smaller regions recursively. Initially, you pick one dimension and split the space into two halls based on that dimension. Then you pick another dimension and split each of those halls into two halls again, and so on. You keep doing this until you have small enough regions that contains only a few points. Each split creates a node in the tree, and the points are stored in the leaf nodes. Efficient search means when you want to find a point in the space, you start at the root of the tree and recursively search down the branches. choosing the split that's closest to the point you are looking for. This way, you quickly narrow down your search to the region where the point is likely to be. Next one is application. KD trees are commonly used in machine learning for tasks like nearest neighbor search, range search, and spatial partitioning. They are especially useful when dealing with high dimensional data where traditional search methods can become inefficient. KD trees are clever way of recognizing multidimensional data to enable efficient search and retrieval, making them valuable tools in machine learning and data analysis.